Good morning, and welcome to Geeky Airplane Stuff, where we examine aspects of aircraft in detail that is so excruciating that it can only truly be appreciated by the hardcore aircraft geeks. This episode is dedicated to the bomb bay doors of the Grumman Avenger. The Avenger is a single-engine torpedo bomber designed by Leroy Grumman & Company in 1940 for the U.S. Navy. The aircraft has many interesting features, like a 2,000 horsepower engine, electrically driven turret, a novel wing-fold mechanism. But I'm going to ignore all these and focus on my favorite feature, a much less famous part of the aircraft, the bomb bay doors. I am a volunteer at the Shearwater Aviation Museum, or as we volunteers affectionately call her, Sam. Sam acquired a flying TBM Avenger from the Forestry Protection Services of New Brunswick. The Avenger is one of 125 that the Royal Canadian Navy operated as submarine patrol aircraft in the 1950s. It had spent its life after leaving the Navy, spraying pesticides and fighting forest fires. The original bomb bay doors were removed and lost when it was converted to carry a water bombing tank. I took on the job of building a set of replacement bomb bay doors from scratch. As a result, I now know more about the Avenger bomb bay doors than is healthy for a sane person. The basics of the bomb bay doors, according to the maintenance manual, are that the bomb bay doors extend from station -33 to station 160 and complete the lower contour of the fuselage when in the closed position. In case you don't know, the fuselage station is just how far along the length of the fuselage something is from a selected 0 point. On the Avenger, the engine firewall is at fuselage station -12. -33 means that the bomb bay doors start about 21 inches ahead of that. It is a bit unusual that the front of the bomb bay extends underneath the engine, but Grumman really didn't have much choice about doing this. The bomb bay had to be at least a couple of feet longer than the Mark 13 torpedo. But Grumman couldn't just increase the length of the nose in order to avoid overlapping the engine and the bomb bay. They had to keep the Avenger short, because it had to be able to fit onto the elevators of existing aircraft carriers. This accounts for the Avenger's stubby appearance, and its nickname of Turkey. The aircraft that Grumman had designed just before the Avenger was the Wildcat. In this photograph, a partially built Wildcat fighter has been pulled off the production line and posed in front of the wooden mock-up of Grumman's new torpedo bomber, showcasing the family resemblance. You can see clearly that the Wildcat has the type of landing gear that folds up into the sides of the fuselage. It also has a continuously curving belly, and its wing is mounted midway in the fuselage, which is an excellent low-drag position. Scaling up the Wildcat was a sensible thing to do because Grumman was a very busy company at the time, producing the largest orders it had ever gotten from the Navy. When you look at this concept model that Grumman created even earlier in the Avenger's development process, you can see that the Avenger was very much intended to be a scaled-up Wildcat. This concept Avenger has the same mid-mounted wing and the same continuously curving belly. Being a bomber, the Avenger needed to have the bomb bay in the place where Grumman would normally tuck in its fold-up wheels. So it had to move the wheels to the wings and use conventional landing gear struts. I chuckled when I first saw this concept model because I could see the folly in it. That continuously curving belly is a nice smooth shape that the aerodynamicists were probably quite proud of. But imagine that you're the one who has to design the bomb bay doors. Doors swing open on hinges, and the pins and hinges are straight, and long doors are going to require several hinges, and all the pins and all these hinges have to be in a straight line for the door to be able to open. Straight hinge lines and curving doors do not work well together. The lovely, continuously curved Wildcat belly of the concept model never survived contact with the structural design department. I can imagine there was a bit of a fight when the structural guys told the aerodynamicists that they had to flatten the belly. In fact, they had to keep the cross-section of the fuselage constant along as much of its length as possible. As you can see here, the top hinge line of the bomb bay door ended up completely straight over its entire length. The doors are two-part bifolds, like many closet doors that you find in houses. So there is a second hinge line a little lower down on the fuselage. It is straight for almost its entire length. You can see that the belly of the Avenger is flat for most of the length of the bomb bay door, but it does gently curve upward at the front end in order to flow smoothly into the engine cowl. The aerodynamicists probably had a little cry over the loss of their smooth belly line, while the structural guys were miffed that they had to splice a formed channel onto the end of the main beam. But aeroplane design is always a series of compromises. The front part of the inner door is not only curved up on the outside, but it is also sloped down on the inside, because the torpedo is mounted in the bomb bay with a slight nose-down tilt. You can clearly see the bifold action of the doors in this front of the open Avenger. A single door panel on each side would have been simpler and substantially lighter, but there's a very important thing that bomb bay doors have to be able to do that forced Grumman to use the bifold. The doors have to be able to swing open while on the ground so that you can load your bombs into the bay in the first place. The bifold is the best way to open the doors without smacking the deck of the aircraft carrier. It also provides a handy step for the pilot to use when climbing up onto the wing in order to enter the cockpit. The back end of the outer door is one of the few movable surfaces on an aircraft that gets marked with a step stencil. If you look closely, you can see the line of rivets securing the half rib that makes this end panel strong enough to step on. Some Avengers even have non-skid painted onto this area. The front end of the door gets the traditional no-step stencil, because Grumman did not intend for it to be used as a step. But it was too darn handy for accessing the engine, so the ground crews ended up using it as a step too. It is common to see an extra half rib reinforcing the front end of the door. This extra rib was a bit confusing because so many Avengers have it, but it does not appear in the engineering drawings. The extra rib was never installed in the factory, but it turned out to be a very common field modification. The extra rib is more common on the left door, because the right door often has a rounded cover on it for accessing the door's hydraulics. The access cover is not so confusing, because it does appear on the engineering drawings. Same drawing also shows the fitting for the door opening mechanism bolted to the front of the outer door assembly. It has a sort of a bone shape to it, with a slight outboard offset on the top that puts the top bearing in line with the piano hinge used along the rest of the door. The offset is to the inside on the lower end, because the piano hinge at this joint is along the inner surface of the door. The top end of this bone pivots in a clevis fitting that is screwed into a stringer in the fuselage. The bottom end pins to the L-shaped fitting on the front of the inner bomb bay door. This L-shaped fitting is connected to a hydraulically driven arm mounted inside the bomb bay. All these fittings in the original Avengers were made of forged aluminum. These days, forging is done when designers need to get the maximum strength possible out of a part. But back in 1940, Grumman was more concerned about making these parts as fast as possible. Milling machines were hand-operated, so even a skilled machinist could not cut a complex shape quickly. Forgings were the fastest way to go because the forging dies quickly pressed the aluminum into near-net shape. After that, only a few simple cutting operations were needed to complete the part. Sam does not have the heavy presses to do forging, but does have access to modern computer-controlled milling machines. Unlike the Wildcat, there was no way that the landing gear on the Avenger was ever going to be hand-cranked up, so Grumman employed hydraulics for the first time. There is a hydraulic cylinder mounted at each end of the door, with a balancing cable connecting them to keep them in sync. There is a tongue-and-groove type latch set mounted near the midpoint of where the doors come together. As the doors are closed, the tongue fitting simply slides into the groove fitting, thereby keeping the two doors from flexing separately. This ensures that the rubber seals on the edges of each door stay in contact and keep the doors sealed. The Grumman engineers did a good job of keeping the door simple. The structure of the outer door consists of a Z-channel running along the top and a C-channel running along the bottom. These are connected by a series of identical ribs at intervals along the length of the door. The slightly curved skin, riveted on the outer surface, locks all this into a fairly stiff structure. The bomb bay is a tight space, so the engineers cut out the ribs in a few key areas in order to make room for the bombs. You can also see that this particular door has the extra half rib in the first bay to reinforce the step area. The structure of the inner door panels is similar, but with the addition of a skin on the inside surface because of its larger size. Grumman was generous with lightning holes in this skin to keep the weight down, and to provide access to the antennas that are mounted on the bottom of the aircraft. Notice this extra large diameter lightning hole just past the midway point? It coincides with where the ZB radio receiving antenna is mounted. In the maintenance manual, there is a mention of a fabric covering over all these lightning holes. It's not uncommon to find fabric covers glued over lightning holes in the spars in front of ailerons, elevators, and rudders. What is odd is that I have seen hundreds of photographs of the bomb bay doors, and never once have I ever seen a trace of this fabric covering. It looks like Grumman initially had a plan to cover the doors, mentioned in the maintenance manual, but then never put it onto any aircraft. The misinformation in the manuals was never corrected before the Avenger left Navy service. The door on the other side of the aircraft also has a couple of larger lightning holes, coinciding with the identify friend or foe antennas. This photo shows the routing for one of these antenna cables to the larger lightning hole. Also, if you look along the piano hinges, you can see little loops of cable every few feet. The pin in a piano hinge is not guaranteed to provide a good electrical contact with the leaves of the hinge because it rotates and it's coated with lubricant. These short lengths of conducting cable ensure that the antennas have a solid ground connection back to the radio set. There is a spot near the rear of the inner door that also interferes with the bombs when the doors are closed. There's a long oval cutout in this particular door, but that's because there's a piece missing. The inner skin is supposed to be recessed into that cutout. The doors in this particular Avenger have been rebuilt from scratch, and that recessed piece is hard to make, so it's been left off. This photograph of the prototype TBF-1 bomb bay shows off the missing part quite well. At each end of it, the aluminum sheet is formed into a compound curve. That is, it is curved in both directions. Compound curves like this are hard to shape with hand tools. Grumman made this part with a huge drop hammer. The people who rebuild Avenger bomb bay doors, Sam included, do not have this kind of equipment at hand. I'm proud that the restoration crew at SAM managed to make this tricky part using a hydraulic ground cart and ingenuity. What we did was to cut the outline of the recessed shape into a thick aluminum plate to make a die. Then we bolted this die to another thick aluminum plate, clamping a soft aluminum sheet in between. We used the hydraulic ground cart to pump high-pressure oil under the aluminum sheet and essentially inflated it up into the die. There were a couple of spectacular failures before we got the process dialed in. The soft aluminum part had to be trimmed, heat-treated, and straightened, but we eventually got a shape that mated well with the ribs. This photograph of the test fitting is for the left side door, so it also shows a bunch of other structure that rebuilders sometimes leave out. In this section of door, the first rib and the third rib connect between the top and bottom beams, but the rib in between them does not. Spanning between these full-height ribs is a short section of beam. This is all done because a short chunk of the bottom beam has been chopped out. You can see all this structure clearly from the inside of the door if you follow the lines of rivets. There are the full-height ribs on each end, the beam across the middle, and the interrupted rib that splits into two short ribs on either side of a hole that is cut right through the bottom beam. You can also see a long doubler plate that helps to carry the interrupted loads around the hole. You cannot see right through the hole in the door because there is a small aerodynamic cover filling it. When you look at the outside of the door, you can see the semicircular hole in the middle of another long doubler on the outer surface. In the center of that doubler, you can see the aerodynamic cover. Note here you can also see the nearby circular doubler around the attachment point for the ZB antenna. Why on earth did Grumman structural engineers cut a hole through a primary beam of their door structure? They did it because their customer demanded it. The Navy didn't specifically require a hole in the door, but what they did ask for was the ability for the Avenger to lay down a smoke screen. It did not take much detective work to figure this out, because it's well explained in the Avenger manuals. Manuals show the Mark V smoke tank cradled in the bomb bay, just like a bomb, with a tailpipe that snakes its way through a hole in the left inner bomb bay door. The tailpipe is offset slightly to the left so that only one door gets a hole in it. In the 1920s, laying a smoke curtain was the first useful job the Navy figured that these flimsy new airplane contraptions were any good for. Ships are expensive assets that the Navy wanted to protect, so they made sure that any aircraft that they operated had the ability to hide a ship. Thus, every Avenger got a hole cut right through a major structural member. The Navy demands that all new aircraft models be tested to prove that they can carry each piece of specified ordnance. Therefore, Grumman dutifully winched the smoke tank into place in the bomb bay and took a photograph as proof of success. The hollow tailpipe is rigged so that when the doors are closed, it ends up passing through the hole in the left door. There is a swivel joint that sits just outside of the closed door. The final section of the tailpipe swings up to run parallel along the bottom of the door, where a support block is bolted to brace it. You know you're seeing a factory-built door, or at least a very accurate reproduction, if you can spot the two nut plates mounted on the rib where the block attaches. There is a lap joint for the skins halfway along the length of the door, where the rivets transition from flush to raised heads. On the front half of the door, the air is still flowing smoothly, so it's worth the extra expense of countersinking each rivet hole so that the rivet head can sit flush with the skin. If you see Avengers with flush rivets on the front half of their doors, you're probably seeing the factory original skins. When the doors are reskinned or rebuilt from scratch, the skins are usually installed with raised head rivets. Not only is this easier because the extra countersinking operation is avoided, but also because the flush rivets that Grumman used are no longer available. Flush riveting was still a new thing when the Avenger was built, so Grumman had to install its own design of flush rivet. The skins used on the bomb bay doors are actually too thin to work with the standard head shape of today's flush rivets. This photograph of the torpedo fitting test captures an interesting feature found only on early bomb bay doors. You can see that the bottom half of the aft end of the inner doors are folded out to form these little wings. What possible purpose can these serve? What we have here is a little door within the bigger bomb bay door. The big clue to the reason for this door within a door is the window in the center of the canted bulkhead at the rear of the bomb bay. This window is the front of the bombardier's compartment. It is sloped forward so the bombardier can look down past the tail end of the bomb load to see the ground. The aerodynamicists probably wanted to help keep the aircraft's speed as high as possible during the bomb run. So rather than open the big old bomb bay doors and introduce pounds of drag, they provided these little itty-bitty doors that could be opened instead. When open, these little doors provide a space just as wide as the bombardier's window, so that the bombardier, or more importantly, his bomb sight, can see the ground without opening the big doors. These doors within the doors are only on the early models of Avenger. They were lost as the Avenger evolved. Perhaps they turned out to be too fragile and were being damaged by the bomb carts. Or maybe a drag study proved them ineffective. Or maybe they just got deleted in aid of production efficiency. There is another feature on the bomb bay door that took a bit more detective work to figure out. What is fascinating about it is that we can determine the exact moment that it was decided to add this feature to the doors. There's another cutout in the same beam with the smoke hole. It's located ahead of the smoke hole and does not go all the way through the beam, but instead only removes the inside flange. The same cutout is made into both doors, so that when they are closed you get a hole on the center line of the aircraft about 2 inches wide, 6.5 inches long, and about 3 inches deep. No mention of this hole is made in the manuals, but it does appear in the Avengers engineering drawings. This means that, unlike the extra rib in the step area, this cutout is not a field modification. A reinforcement angle, which was added to the top of the beam to compensate for the cutout, was given a very high item number on the drawing, -110. This tells us that the cutout was a late addition to the drawing. A note on the drawing states explicitly that the cutout is only used on the TBM-3 models. This got my curiosity up, and I really wanted to know why it was there, so I started scouring the drawings for some kind of hint of what the cutout is for. I tracked down every drawing I could find related to the bomb bay door assemblies, By tracing my way through the where used information across several drawings, some of which were barely readable in the smudgy title blocks that you find on old microfilms, I finally found a drawing that detailed how the various bomb loads are secured in the bomb bay. The drawing includes the arrangement for securing the 2,000-pound bomb. There I found some sort of lug on the bottom of the 2,000-pound bomb that looked like it could possibly interfere with the outline of the inner door. What is this lug? I searched through the drawings of all the doodads that hold the bomb in place, and the lug is not part of that gear. The lug must be part of the bomb, so I went looking for data about the 2,000-pound bomb, and I was able to confirm that the lug is indeed a suspension lug welded onto its casing. It coincides with the center of gravity, and the bomb is supposed to hang from it when attached to an aircraft. But if it's a suspension lug, then it should be at the top of the bomb, not the bottom. The reason it is at the bottom is because of cooperation between allies. The bomb is designed for interoperability. That is, it's designed to be used by both American and British armed forces. The Americans use a double lug suspension system, while the British use a single lug suspension system. The single lug is mounted on the opposite side of the bomb from the double lugs. If you are British, you just flip the bomb over and hang it from the single lug. Grumman designed a new arrangement for securing the 2,000-pound bomb in the TBM-3. This meant that the ordnance proving test had to be performed again. This photograph from the 23rd of June, 1943, shows the 2,000-pound bomb undergoing that test. The Avenger is an American aircraft, so naturally the bomb is mounted with the double American lugs on the top and the single British lug on the bottom. If we track straight up from the British lug, we can see that its location does indeed coincide with where the cutout is within the bomb bay. Going through the ordnance proving test photographs, we can see that the cutout received close attention. This photograph may be in black and white, but we're still able to see that there's no paint along the edges of the cutout. We can also see scratches near the cutout, where tools have recently left their mark. We can also see a bare patch of unpainted aluminum and an exposed bolt hole, where the tongue and groove latch used to be located before it was moved back a rib in order to get it out of the way of an added reinforcement bar. And this reinforcement bar is not installed with rivets, like it would be on the production line, but is installed with slot head screws. What all this tells us is that the engineers designed the new 2,000-pound bomb installation in such a way that the lug on the bottom of the bomb kept the doors from closing. This defect was not noticed until the ordnance proving test. Technicians then whipped out their tools and cut the necessary notches and added the reinforcements. With this last-minute modification in place, the bomb bay doors could be closed and the TBM-3 Avenger passed the ordnance proving test. The new cutout was added to the door drawing, which was then distributed to production so that all TBM-3s would be capable of housing the 2,000-pound bomb. I'm absolutely chuffed that my detective work was able to find out the exact day that this particular design problem was fixed. Wednesday, June the 23rd of 1943. I hope you enjoyed this overly detailed exploration of the Avenger bomb bay doors. Now you'll be able to amaze your friends the next time you encounter a Grumman Avenger at an air show. If all this is going on with an easily overlooked feature of the aircraft, just imagine how much more there is to discover during your next adventure at your local aviation museum. Head on over and I'll see you there.